In this next section, we're going to be dealing with the graphs of secant and cosecant functions. We've dealt a lot with the graphs of sine and cosine, and we know that the graphs of the cosecant and the secant are the reciprocals of the sine and the cosine. All right, and so we can determine some features of the graphs of the the secant and the cosecant based upon what we know about the sine and the cosine. All right, so what I have drawn up here is just a quick sketch of, or rough sketch of one period of the sine and the cosine function, the period from 0 to 2 pi that we often use, along with the 5 key points, okay? We know that the sine has a period of 2 pi. The 5 key points are at 0, pi over 2, pi, 3 pi over 2, and 2 pi. And it has an amplitude of 1. It goes up to 1, down to -1. The cosine is a pi over 2 shift to the left of that function. And so it has the same 5 key points, but its x-intercepts are at pi over 2 and 3 pi over 2 rather than 0 pi and 2 pi, okay? Again, its maximum and minimum are at 1 and -1. And so we can use some of this information then to determine information about the cosecant and secant. So let's focus on the cosecant for just a moment. Remember that the cosecant is the reciprocal of the sine, right? Cosecant is the reciprocal of the sine. And so any output from the sine function is going to be flipped, okay, or we find the reciprocal of it in order to get the cosecant value, all right? So at 0, at 0, with an x value of 0, the sine has an output of 0, right, a height of 0. When you take the reciprocal of 0, you get 1 over 0. Well, what's 1 over 0? It's undefined. What you hopefully will remember from our discussion about the tangent and the cotangent graphs is that when you have an undefined value, at least with these trig functions, you end up with something called a vertical asymptote, okay? You will also end up with a vertical asymptote in both the cosecant and secant functions when you're looking at an undefined value, okay? So we're going to basically have a vertical asymptote right here on the y-axis, okay? Likewise, at pi and at 2 pi, we're also going to have vertical asymptotes because the reciprocal of the 0, the x-intercept, is undefined, okay? So there's going to be a vertical asymptote at pi and at 2 pi. All right, so there's some features of the graph there. Now at 1, right, or at pi over 2, sorry, the output is 1. The reciprocal of 1 over 1 is 1, right? Reciprocal of 1 is 1. And so at pi over 2, the cosecant is also at 1, okay? In addition, at 3 pi over 2, the sine function is -1. The reciprocal of -1, 1 over -1 is -1. So that one won't go anywhere. So at 3 pi over 2, the cosecant is also -1, right? The reciprocal of -1 is -1. Okay, so now we've got to figure out what happens between 0 and pi over 2, between pi over 2 and pi, between pi and 3 pi over 2, and between 3 pi over 2 and 2 pi. So in those different regions, you could also think of them as the 4 quadrants, with a circle with the angle opening around. So between 0 and pi over 2, the sine function is positive, which means its reciprocal will also be positive. So I know the graph is going to be above the x-axis. But more than that, I know the sine value is between 0 and 1, right? It's in between 0 and 1. When you take the reciprocal of a number between 0 and 1, or in other words, divide by a number between 0 and 1, you get a number greater than 1, right? So if I took the reciprocal of a half, for instance, it would be 2. The reciprocal of 1/10 is 10. And so you take a small number and take its reciprocal and you get a bigger number, okay? A number smaller than 1 becomes a number bigger than 1. And in fact, what happens is, from this point at 1, the graph will shoot up to the left toward that vertical asymptote, okay? So the reciprocal of all these positive values between 0 and 1 is a positive value greater than 1, or between 1 and infinity, okay? And I know it's going to go up and to the left because that's where the asymptote is. Now between pi over 2 and pi, a similar situation occurs. We have positive values between 0 and 1, and so the reciprocals will be positive but greater than 1. And so it will curve up and to the right toward the vertical asymptote at pi. Okay. With a similar argument, you can show that in the third and fourth quadrant angles, reciprocals of negative numbers are still negative, but because they're between 0 and -1, they're now going to be, the reciprocals are going to be less than -1, further down toward negative infinity, okay? So from this point at -1, we're going to go down to the left toward the asymptote. And also on the other side here, the fourth quadrant angles are again negative, so the reciprocals are negative. Because they're between 0 and -1, the reciprocals will be less than -1, further down between -1 and negative infinity. And so the curve goes down and to the right toward the asymptote. Okay? And so you have these two disjoint or two separate curves that are pinned between vertical asymptotes, consecutive vertical asymptotes. There are no x-intercepts, right? Because if there were x-intercepts on the cosecant graph, then when you take the reciprocal to get the sine, you would get vertical asymptotes. Since we don't have vertical asymptotes in the sine, there cannot be any x-intercepts on the cosecant. All right, so the cosecant has, on this one period, from 0 to 2 pi, you have 3 vertical asymptotes, you have no x-intercepts, and you have 2 sort of disjoint curves, or disconnected curves, and they're each pinned between sets of consecutive vertical asymptotes. And if you were to continue the graph of the cosecant in either direction, what you will find is that at every integer multiple of pi, 2 pi, 3 pi, 4 pi, 5 pi, negative pi, negative 2 pi, negative 3 pi, and at 0, all the integer multiples of pi will have a vertical asymptote associated with them. All right, so out here at 3 pi, there will be another vertical asymptote, and so on. And the graph will alternate between these two curves. Okay, so the next one over will be the positive side. So it starts at 1 in the middle and shoots up to the asymptote on either side. And then here it started at -1 and shoot down, and so forth. Okay, so that's the general trend of the cosecant. Again, the period is still 2 pi, right? So the period between the cosecant and the sine are going to be the same. It's just, we're going to end up having to deal with the vertical shifts, the phase shifts, and the period changes, and the amplitude changes. So we're still going to have to deal with all of those transformations in a little bit. But let's first establish the graph of the secant before we get into that. So the graph of the secant, you can probably imagine, is very similar to the graph of the cosecant, because the cosine is simply a shift. It's a phase shift of the sine by pi over 2 to the left. And so the graph of the secant will be the graph of the cosecant by a shift of pi over 2 to the left as well. In that case, the graph, and you can argue it basically from the cosine as well. You can say that, well, at each of these x-intercepts, it's going to correspond to a vertical asymptote on the secant. So pi over 2 and 3 pi over 2 where there were x-intercepts, there's now going to be vertical asymptotes. And in fact, at every odd multiple of pi over 2, there's going to be a vertical asymptote in the secant. And then again, in the middle section here, you have all negative values. So you would have a region that goes, or a curve, starting at -1 here at pi, and going down to both the left and the right toward those asymptotes. Between 0 and pi over 2, you have positive values of the cosine. And so the secant, starting at 1, will go up to the right. And then on the right side here, you have the positive values again. So starting at 1, you go up and to the left, right? Now, I'm not sure if I got those lined up very well, but you get the idea. So it's essentially a shift of the cosecant graph left by pi over 2. Right, so you're essentially looking at this much. I don't know if you can see the pi over 2 to 5 pi over 2 region of the cosecant graph. It's shifted now. Okay, and of course this would continue if I added more spots over here, more asymptotes. The graph will go up to the right and then down in between and then up and so forth. Okay, so it just kind of keeps going down the line between the consecutive asymptotes, and if we go left, does the same thing. So now just to kind of summarize some features of the cosecant and the secant. First of all, the period is still 2 pi. Or when you multiply, remember we had if we multiply on the inside in the argument, like b times x, it'd be 2 pi over b. It's the same sort of period formula. For the cosecant, the vertical asymptotes occur at every integer multiple of pi. So an integer would be like n times pi, right? So x equals n pi, where n is an integer. Okay. In addition to that, the domain is all the x values that make defined outputs. The undefined outputs are at those integer values of pi, integer multiples of pi. And so the domain is going to be everything except those. So the domain is all values of x, where x is not equal to an integer multiple of pi, n pi, where n is an integer. Okay, so that's your domain. You can use any value of x except for multiples of pi. The range, remember the range are the outputs for a function. And so the outputs for the cosecant are everything above 1, including 1, and everything below -1, including -1. In fact, nothing between -1 and 1 will be in the range. So the range includes 2 intervals, from -infinity to -1, that's the lower interval, and the interval from 1 to infinity. So all of the outputs are going to be either greater than 1 or less than -1 in one of those two regions. Okay, so now let's take a look at the same stuff for the secant. The secant has a period also of 2 pi, or again, if it's the secant of bx, it's 2 pi over b. The vertical asymptotes here are going to be all of the odd multiples of pi over 2. So 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and so forth. So those are odd multiples of pi over 2. To get an odd number, you take 2n plus 1 and multiply that by pi over 2, where n is an integer. give you all the odd numbers times pi over 2. The domain are going to be everything except for those vertical asymptotes, or the odd multiples of pi over 2. So the domain, again, the x values are going to be all x's such that x is not equal to an odd multiple of pi over 2, again, where n is an integer. And the range, well, the range is going to be your y values, and those are going to be the same. It's going to be everything greater than 1, everything less than -1. Okay, so negative infinity to -1, and 1 to infinity, those two intervals. Now, something that's kind of interesting, a way that I like to graph the cosecant and the secant is actually to plot the graph of the corresponding sine or cosine function, and then just draw the cosecant and secant in after that. Gives you kind of a clue as to what you're looking for. So if you look at this, if I were to kind of overlap the sine function with the cosecant, you'll see that the sine function can help you to plot the cosecant. Continue that on, okay? And you can see they kind of meet up at certain places. At the peak and the valley of the sine function meets up with the cosecant function, and they go in the same sort of direction. So when the sine is above the x-axis, the cosecant is, and when the sine is below, the cosecant is also. Similarly for the secant, if I were to transpose the cosine on top of this graph, it would start at 1, it would go down to -1, up, and then back. And you can kind of see where the secant graph is down here. It kind of meets up with the cosine at the bottom, and it does so the same on top. Okay, so you can kind of see how the two graphs are related to each other. So I like to plot out the cosine or the sine, and then just at each of the x-intercepts, I throw a vertical asymptote in for the other function, and then plot the graphs accordingly. Okay, I think that helps to get all of the other pieces of information correct. It helps you get the period, the phase shift, the vertical shift, and what was the other one? Amplitude. My goodness, amplitude and reflections. Helps you get all that stuff in the right place, and then to plot the graph correctly. So we'll start. I'll get some examples going in the next couple videos here, and you'll see how all that plays out.